This is the Engines of Our Ingenuity, made possible by the friends of KUHF Houston.
Today, the Vanishing Sextant. The University of Houston presents this series about the machines that make our civilization run and the people whose ingenuity created them. During a recent visit to the Royal Astronomical Society in London, I had a chance to hold a sextant that once belonged to Captain James Cook. Never mind that it didn't actually go with him on any of his voyages, here was an artifact connecting me to one of the great explorers and navigators of all time. No single object is so iconic of ocean voyaging and navigation as the sextant, and this was a beauty. Beyond that, the sextant occupies an interesting place in the evolution of navigation. Finding latitude, the line on the Earth north or south of the equator, requires measuring the angle between the horizon and a known object, such as the North Star, Polaris. This has been known by mariners for at least a couple thousand years. Measuring this angle required the navigator to sight two objects, say Polaris and the horizon, simultaneously. This could be done crudely, with outstretched arm and fingers, or with straight sticks held at a common distance from the eye. Difficult enough on land, much more so on a pitching, rolling deck. The less accurate you were, the less confident of your position on a chart, and the more extra distance you might go. I vastly simplify a fascinating history here by noting that many devices were developed over centuries to improve this measurement, such as the quadrant, the astrolabe, and the cross staff. A breakthrough came in the early 18th century, nearly simultaneously by Englishman John Hadley and American Thomas Godfrey. Each discovered that using two mirrors, a celestial object's image could be reflected onto the same plane as the horizon being sighted by the viewer. Adjusting the arm of the mirror sighting the star to bring its image level with the horizon, one could read the angle between the two against a scale on an arc. With this reflected optics scheme, measurements over 1/4 of the sky, or 90 degrees, could be made using an arc of 1/8 of a circle. This device became known as the mariner's octant. To measure objects greater than 90 degrees above the horizon, the arc was expanded to 1/6 of a circle, from which we get the word sextant. The sextant reached its mature form by the mid-18th century and has remained basically unchanged since that time. Over the last few decades, celestial navigation has been largely displaced by long-range radio navigation and the satellite-based Global Positioning System, or GPS. Unlike the skill-intensive practice of celestial navigation, very little understanding of the GPS system is required of the user. Any of us are just a button push and a few seconds away from determining our exact position. Many of us carry phones that can do this. And so we can lament the fading of a beautiful instrument with a romantic image. It's doubtful that the silhouette of a GPS box will ever grace a travel documentary or adventure novel. But we can celebrate the sextant as the symbol of applied celestial navigation, the jumping-off point from which one superbly matured technology was superseded by another. And as wind and sails remain to drive a ship should we decide to avail them, so the sun, moon, and stars await our need to find our way. It is only a matter of what means we use to read them. I'm NASA astronaut Michael Barrett for the University of Houston, where we're interested in the way inventive minds work.